so this is example 11 in lesson 7.4, and I've drawn out the diagram already. So we've got a block, it says it's got a mass of 2 kilograms, it's being pushed up the plane by a horizontal force of magnitude 25N, so I've drawn it in there, and it's moving up because it's telling us it's being pushed up. It tells you the angle is 10 degrees, and it asks for the coefficient. It tells you the coefficient of friction is 0.3, and it asks for the acceleration of the box. So firstly, let's fill in all the other things we can on this diagram. So we know that there's a reaction force there that's going to be important for generating the friction. Seeing as it's moving up the slope, we know that friction will be opposing it, so friction will be sending it back down the slope. We know that this angle here is 80, alright, because it's a right angle triangle, so they'd add up to 180 with the 90 degrees that would be down here. And then we just find the angle that it's going to make with the slope of this force here. So although we can't really see it as clearly from the diagram, it's actually a Z angle, right? If this is horizontal, it's parallel to the floor, which is going to mean that this angle in here is going to be 10 degrees as well, right? Two parallel lines, line between them, Z angle, means that they've got to be equal. Okay, so I think we should be ready to go and try and do some maths at this point. So remember, we're going to resolve, because it's a slope, we're going to resolve up the slope in the direction of the slope, and we're going to resolve perpendicular to the slope. So let's do the perpendicular first. Okay, so we've got R going up, that's the only thing pushing out of the slope, and this is the bit that people often miss. The horizontal force is actually pushing it down into the slope, right? So it's shoving it up, but because it's not just parallel with going upwards, there's got to be some component that 25 is actually shoving it into this slope. So it's going to oppose the reaction, right? It's going to increase the reaction force because it's pushing it into the slope, which is pushing the box down into the slope, and the reaction is the other way. So it's 25, and then if it's 10 degrees to here, that means that we've got to go away from the angle to get it to the direction of R, which means it's going to be sine 10. Of course, you've also got the weight pulling it down, and that one's a bit clearer. It's 2g sine 80, right? Because we're trying to get to this perpendicular here. It's the horizontal one that people really struggle with, right, understanding. And it's just seeing that that is pushing it down into the slope. So actually, they're all just numbers that I can calculate. So let's get my calculator and see what that is. So this is going to be 25 times sine 10 plus 2 times 9.8 times sine 80. Okay, we get 23.64 newtons for R. Right, but R is not what we're looking for. We're trying to get to A. So to do that, we're going to have to resolve up the slope. So let's have a look. What's pushing it up? Well, it's this 25 Newton force. So the force is 25, but it's not pushing it straight up. It's 10 degrees out. So it's 23 cos 10 through the angle, minus the weight pulling it down. That's 2g cos 80. And of course friction, which will be pushing it in the direction of the slope. So anytime we're doing friction, that's going to act parallel to the direction of the slope. So this is minus friction. So this is 25 cos 10 minus 2g cos 80, and then it's mu r, isn't it? And we know mu and we know r. So it's 0.3 times 23.64. That can all be calculated, they're just numbers, so let's calculate that now. So it's 14.1247 newtons to 4 decimal places or whatever, because we're going to use that in the next step. So now we've got the force, that's how much force is being applied up the way. So we can now do F equals ma, so 14.1247 equals 2, that's the mass, times A, that's what we want to find. So A is whatever that is, divided by 2, use the full calculator accuracy I've got here, and I get 7.06 meters per second squared to 3 significant figures. So it's accelerating up the slope at 7.06 meters per second squared.